Before we tackle lighting, let's take a look at the Render Setup dialog, as lighting and rendering are closely related. The Render Setup dialog can be accessed from the main toolbar or by pressing the F10 hotkey. For this movie, we will concentrate on the Common tab. Here, you define what you want to render, be it a single image, the current frame, the whole animation, or a partial animation by specifying a range. You can also define the output size. The default is 640 by 480 pixels. You can also choose from a variety of presets. For example, HDTV presents you with output options in 1080p and 720p among others. If you make a change to a value, such as setting a custom width of 800, the height is automatically adjusted to preserve the current image aspect ratio. The Render Output group enables you to specify an output file if and when you wish to save your image to disk. You get a choice of multiple file types based on industry standards. You usually do this when everything is in place and you are ready for a final render. Finally, expand the Assign Renderer rollout. The default rendering engine is set to Scanline Renderer. A rendering engine takes into account all your scene information, geometry, materials, lights, camera angles, and so on. It then converts all this information into an image when you click the Render button. The two main production rendering engines are the Scanline Renderer and the Mental Ray Renderer. The Mental Ray Renderer is more powerful and far more accurate and should be used whenever possible, as you will discover shortly. For the time being, leave the default Scanline Renderer active. If you close the Render Setup dialog and wish to test render the scene, you can use the Render Production icon on the main toolbar or press F9. The Render Production icon will render the scene with the values you set up in the Render Setup dialog. Next, let's take a look at some basic lighting concepts. Lighting a 3D scene has come a long way in the last few years. In the early days, the art of lighting a CG scene convincingly was a very hard process. It called for the insertion of multiple light sources and adjusting them endlessly to create an acceptable result. Although it worked in some cases, the results were typically far from accurate, mostly due to a limitation of the software. This has changed since then. If you look in the lighting panel in 3ds Max, you will see two main categories: photometric and standard. The photometric lights are physically accurate and properly simulate lighting in the real world. Lights can be targeted, such as for simulating a flashlight, or free for simulating a light bulb, for example. When you choose one of these options, a dialog appears. Dismiss it for now. This will be discussed later in more detail. Photometric lights are based on real-life counterparts. This means that if you need to place a 60-watt lamp in the scene, you should choose a 60-watt lamp from a template list. A word of caution: photometric lights are meant to be used with the MR or Mental Ray Renderer. Another important factor for using photometric lights is that the scene has to be built to scale. We'll come back to photometric lights a bit later. For now, take a look at standard lights. These aren't physically accurate, and finding the correct values involves a lot of guesswork. We'll concentrate mainly on three types: Omni, Spot, and Direct. An Omni light, sometimes referred to as a point light, shoots out rays in all directions like a light bulb. Because of that fact, it illuminates the whole scene, and any shadows it creates are dependent on its position in space. A spotlight is similar to an Omni light, except that its range of illumination is controlled by a cone that you define. A direct light is slightly different. It is somewhat similar to a spotlight in that its range of illumination can also be controlled. However, the rays it casts always run parallel to one another, like a laser beam, and the shadows it casts are therefore parallel also. The purpose of a direct light is to simulate the sun. One can assume that the sun is a point light in outer space. However, because of its great distance to Earth, the light beams that reach us are practically running parallel to one another. In a 3D scene, it is easier to place a direct light to simulate the sun rather than an Omni light that is 150 million kilometers away from the center of the scene. An Omni light, a free spot, or a free direct are created with a single click. And then moved or rotated into place. A target spot or a target direct is placed with a click and drag, and then its position and orientation are controlled by moving the light or its target. Delete all lights from the scene. In the top view, place an Omni light in the top left corner. Notice that when you place a light in the scene, it affects the viewport's display. In the front view, move the light up so it's above the scene. Right-click the camera view and render it by pressing F9. The test render has many problems. The single light is illuminating the scene from one side, but the other side is totally dark. This can be seen on the sides of the buildings and the Jeep. In real life, light bounces off surfaces to illuminate a space from all sides, rather than a single direction. Another problem is the total lack of shadows. It gives objects a floating feel in the scene. It also gives way to another problem, such as the illuminated interiors we see inside the barracks. With the Omni light selected, go to the Modify panel. Here, you can make adjustments to the light intensity and color, among other things. Notice that the light intensity is based on a multiplier value, rather than an industry standard value. Set the multiplier value to 2. Enable the Shadows option and render again. The render is a little better, but not by much. The scene is brighter, but still extremely dark on the side opposite the light source. Shadows display, but they don't look very accurate. The default Shadow Maps option is fast to calculate and produce soft shadows, but Shadow Maps only approximate shadow projection. From the Shadows drop-down list, choose Ray Traced Shadows and render again. This time, the shadows are crisper and more accurate. To illuminate the dark areas in this scene configuration, you'll need to place additional light sources. These could be additional Omni or spotlights, usually with a small multiplier value and no shadows cast. However, and as mentioned earlier, this process involves a lot of guessing and the results aren't usually very accurate. Instead, go back to the Render Setup dialog. And switch the rendering engine to the Mental Ray renderer. Now the render window has more options in it. And when you render the scene, the rendering window processes the image in buckets. The rendering time is also slightly longer. This is because Mental Ray automatically calculates all the bouncing light to illuminate the scene from all angles. The scene certainly looks better now, yet it's still not physically accurate because an Omni light is not a physically accurate light. In the next movie, you will light a scene using a daylight system, which is a physically accurate light used to simulate the sun.